Hello, this is Liao. This is the second question of homework 11. This question is about to find the property of the autocorrelation and the spectrum, and it gives us a different f, and we will see if it valid when f equals to autocorrelation function or spectrum. So first of all, we should see the when here f equals to that's this guy, and we assume that it is the autocorrelation function r tau, and we use Fourier transform because the relationship between the spectrum and autocorrelation function is by Fourier transform. So we use the Fourier transform formula, and we try to find the spectrum. This process is all about the Fourier transform, and we finally get the answer, this guy. And now we evaluate this. Here we can see it is the even and non-negative. And the autocorrelation function, this guy, and is exactly like this, is also even, right? And when it's tau equals to 0, it should be, and it must be the largest value. So because you can see this value when they grew up, the value is decreasing, right? So R0 when tau equals to 0 is larger than any guy. So we can see it is valid. Okay, another case, we say if it represents spectrum, and we use inverse Fourier transform to find the autocorrelation function. And the process is about the calculation about inverse Fourier transform, and finally we get this answer. We say it is even, right? It is even, and when tau equals 0, it is the largest value. And from before, we see this guy is because we assume it is spectrum, and we evaluate it, we see it is even and it is non-negative. So the spectrum is even and non-negative. So it's valid. Okay, B, it is the F is like this. There are some trick, and it also have the physical meaning of this guy. First, we use this trick. We define a new guy, SA tau. SA tau is like this. So after we square it guy, we will find it exactly the F way. R tau equals to square SA tau multiple SA tau. Remember this is the Fourier pairs we already know, because the SA tau we already know. We are very familiar about this. It's exactly equals to like a rectangle function. So we can see here or SA tau is this guy, or we can use a different expression. And finally, we see here we want to find R tau, but R tau is the square of SA tau. So SA tau multiple SA tau. This is in time domain. The multiple in time domain is equals to this guy in frequency domain. So I try to find this guy in frequency domain and finally get this answer. And now I will find from the graph. I sketch it, and find it is like a rectangle. Not rectangle, I'm sorry, triangle. So the SW looks like triangle, like this. So I see it is even and non-negative. And also, we see from this guy, we can see it is even. And when V equals to 0, it is the largest one. Why? When V equals to 0, the sin tau equals close to goes to tau, and so the R0 equals to 1. But other guy, that when tau equals to the other guy is smaller than 1. So R0 larger than R tau. So it's valid. But when it represents SW, we find the autocorrelation function is triangle as well. So we see the autocorrelation function is even and fulfill this formula. And the spectrum is even and non-negative. It's valid as well. See, if we assume this guy represents R tau, but I see the spectrum, because we already know if this is the autocorrelation function, after we find its Fourier transform shape, we will find a sinc function. So that's I already know. So I see the spectrum is a sinc function. It has a negative value, so it's not invalid, because the spectrum should not have any negative part. So when another case, when it represents SW, the spectrum, the R tau is an impulse. That's I already know. Impulse. So here we will see this impulse, and actually I can put any amplitude in here, but I don't worry about that. I just say its style is impulse. So R0 larger than R tau. The tau is another value. And R0. Oh, sorry, here. And R tau is even, because they only have one value when tau equals to 1. It's on the center point. The spectrum is even and non-negative, so it's valid. So that's all.